Everybody remember Pac-Man? Can you imagine a version of the game where Pac-Man is only able to gobble up a single ghost? You're playing the game, you catch a ghost, and then game over? That wouldn't be a very fun game, and it wouldn't be an efficient way to clear out all these ghosts. That is exactly the problem with many modern drugs. They function against their targets at a 1-to-1 ratio at best. You need as many Pac-Men as you have ghosts. Here's a good example: antibodies. Currently, there is a tidal wave of therapies and clinical trials based on the highly specific ability of antibodies. These remarkable proteins bind to inactivate all sorts of targets with extreme specificity, but they are used up in the process. What if we could create a drug that could act on one target after another, after another, after another, like Pac-Man eating ghosts? What I'm describing is enzymatic turnover, the ability of a protein to act on its target and then move on to act on another target. Fortunately, this kind of activity already exists. Proteins that cleave other proteins are called proteases and are relatively common. However, our ability to engineer a protease to cleave a specific protein is in its infancy. This is the goal of my thesis: to create a protease that will cleave a specific protein toxin. This potential drug will combine the specificity of antibodies with the power of enzymatic turnover. Here's a fun fact about Pac-Man. The red ghost's original name wasn't Blinky, it was streptococcal pyrogenic exotoxin A. Of course, that's not true, but that toxin, SpA, does cause a wide range of human disease, including the flesh-eating disease necrotizing fasciitis. I am creating a protease that will specifically destroy this toxin and therefore be a potential drug for numerous human diseases. So, how am I making this special protease? The key is I'm applying the principles of Darwinian evolution in a test tube. First, I create a pool of over 1 trillion protease variants. Then I pick out the best one. That's like picking Albert Einstein from a pool of 10 times more than how many humans have ever lived. I am working towards creating the first of a new class of drugs, proteases capable of specific destruction of bacterial toxins. In the future, I envision expanding this field to create custom Pac-Men to gobble up the ghosts of autoimmune, inflammatory, and coagulation disorders. Thank you for your time.